everybody. My name's Feiyang Tang. I'm ESR 11 in the NR Norwegian Computing Center. My project is about detecting privacy defects in software. My main supervisor is Beate Erstvold in NR, and I have another two co-supervisors, Store and Raymond in Anthony and Twinter. First, a little bit about me. I was born in a mid-sized city in eastern China. Then I moved to Auckland, New Zealand when I was 16. I have a bachelor's degree in software engineering. Then I did my honors degree in computer science from Auckland University. After that, I moved to KU Leuven. I got my Master of AI there. I had experiences in various university AI labs before I moved to Norway, in both New Zealand and Belgium. My honors project was on data stream mining. And in Leuven, I was in the language and information retrieval lab working on a project. Actually, we're trying to do a bidirectional search between image and text. To enable more functionalities, for example, for the museums or these kind of galleries, enable users to do more enhanced search. Now let's move to my topic. First, I want to differentiate the definition of privacy and security. So we start from a simple example. Let's think about our apartment buildings. Every apartment buildings, we have this gate and doorbell on the ground floor. This could ensure the security of all the residents. But to better protect their privacy, each resident can choose different kinds of curtains in their own rooms to achieve different levels of personal privacy. So basically, the former security can exist without the latter privacy, but not on the other way. Also, moreover, we say that data security is actually the main prerequisite of the data privacy. There are plenty of mature studies in the related topics. We have many excellent program analysis tools to find security bugs in software now. We also have many formal methods to check the compliance for privacy or security related legal clauses in both legal documents or the contracts made between companies. On the design level, there are also great research on threat modeling and apply privacy by design during the process of the software development lifecycle. So, however, the definition of privacy defect in software has not been clearly written down yet. So this topic is actually under studies. In this project, we'd love to know first what privacy defects are and how we can detect their presence using program analysis. Afterwards, we want to extend the definition and also check the specified privacy requirements in the legal documents and contracts for their compliance in the corresponding software. Also, if possible, we'd like to provide bits of advice to the developers. There are three common occurrences in software privacy violations. First, personal data sometimes does not get properly stored. This includes aspects like inappropriate data retention period, encryption and unprotected queries, etc. We also need to consider private data leakage caused by the inference as well. So we have a little example here in the bottom, which shows a bad practice of the SQL query. So basically, this is what we call SQL injection attack. Basically, it asks from the users for the user ID, but actually, if you input something like 105 or 1 equals 1, then it will just expose all the confidential data to a third party, to basically everybody. So this is a very, very simple example, like it's a really bad practice to store data or transfer data. Then there are permission and authentication and authorization are also very, very crucial to ensure privacy. Insufficient permissions or inappropriate permissions are very, very risky, actually. So here is a small example of the Android Java code, which processes confidential user data, such as location data and the IMEI of the device. So we've noticed like the snippet, it leaks user identifier on start, that function, and the user's exact location on location changed this function as well. Both leaks occurs in the send function, which is outside of this application. All these actions are performed without appropriate authorization from the users. Besides this, it is also very important to not leave any sensitive data in the logs, both internally, externally, or to the third party, or on the error message board. So you're not supposed to display any kind of sensitive or personal data on these kind of logs or error messages, or even on the end devices interfaces. For this project, we firstly want to quantify the sensitivity of the user data. So most of the security defects, they only become privacy related when the data involved are considered sensitive or personal. Then we want to apply program analysis mechanism on some open source software to find these defined privacy defects we just defined. Then we apply program. Then we also want to avoid these privacy violations caused by the inference attack using some techniques such as differential privacy. Meanwhile, we also want to support privacy by design in our work, which is instead of you find these existing privacy defects, we want to prevent the occurrence of these privacy violations in the future. So I'm going to have two secondments. The first one will happen from the month 17th. First, I will go to Twitter to join Amina ESR 9. So we want to, the expected result, we want to get a secure software implementation of the protocols. The second, I'll go to the company SecureNet, where I would love to apply the methods in the real-world commercial applications. That's all about me. Thank you guys for listening.
We're unmuted. Okay, thank you, Feiyang. Are there questions?